everyone, welcome back to my YouTube channel. Hope you are all well. It's been a while since I uploaded the video. Today it's going to be something a little different. So, as some know, I have designed a smart glove to monitor the hand joints for rheumatoid arthritis diagnosis and rehabilitation. So, okay, so where do I start with this one? So, I have 5 or 6 components belonging to my data glove sitting on this table, and they're all 3D printed. Well, hold on a minute. So basically, we have 5 components there, taking away these ones. These are just samples. So this video is going to be about building a wee small unit, system, machine for cutting tracks in this rubber. So some would say, if it's 3D printed, why do I need to cut tracks in it? Well, that's because this rubber is, well, it's very flexible and elasticity is a high level. So it's basically, it stretches and you see. So basically it's very elastic and very flexible, much like a rubber band. So this sits on a rubberized texture thing that's printed too. I'm not going to say too much about the data glove, I'm only going to talk about the machine. But this is the base box that sits on the wrist for the battery and Wi-Fi and stuff like that. Bluetooth. So obviously we need to connect these boxes together in the glove, and also needs to be flexible in order for the boxes to move nice and neat on the hand and wrist without any obstructions. So I have designed this piece of rubber. I started off with this one. So the rubber is designed around what I can print, basically. So I then moved to this shape, and then I was getting failures and stuff because it's very hard to print. It's being so elastic, so flexible. Okay, so then we ended up with the final pieces. These are only samples at the minute. So basically there needs to be a hole in the middle for the cables to go through. Flexible cables, ribbon strips. So ribbon cables. So we have here 5 or 6 pieces. So what I'm going to do here now is I'm going to start talking about what I need to do to this. So in order for me to place this rubber piece into the glove, it needs to be tracked right around this edge. But as I say, trying to get this level of resolution with elastic resin and a 3D printer is impossible. So what I'm going to do is I'm going to make a wee machine, a wee small system to cut the tracks after they're printed, and then they will slide into the base unit on the hand and then onto the wrist, which has the same slot as can be seen here. So you see the slot here and here, the rubber will slide into the 2 of them. So these pieces I have designed, I don't know, 6 months, a year ago even, maybe longer actually, maybe 2 years. It started 3 years ago. Okay, so where do we start now? So this is the wee cutter that I have got to cut the tracks. This cutter is actually used for cutting treads and tires, and it's sharp. It's like a standard bit at one end. It's basically a hard bit of spring steel, sort of. Me squeezing it here. So what I'm going to do is I'm going to put a high current through this. So I'm going to, you're probably thinking where I'm going to get the high current from. So I'm going to rip a transformer out of a microwave and alter the secondary winding to create a high current. This current doesn't need to be that high because this is only a wee thin piece of steel, but high enough just to melt or to run through the rubber itself. Don't want it to go too hot because I don't want the rubber to go on fire or go on flames. So basically I'll be taking it up to just till it's touching red, if not a wee bit below it. I don't know, maybe a couple of 100 degrees. Okay, so next step now is getting the transformers. So I'm going to get 2 transformers. So the reason I want 2 transformers is because the cut is deeper in the edges than it is the top and the bottom. So see the glove box here? See the wee edge at the bottom? It's not as deep as it would be when the rubber is placed into here. As you might be able to make that out in the camera there. So when I'm cutting the rubbers, I will also place a piece of metal on the inside of the rubbers to keep its shape, because as you can see here, It's very flexible, and when I'm cutting the top edges, you want it nice and tight to the platform that I'm going to be cutting on. So now moving on. So once this rubbers is placed into the glove box, I then have lids to hold the rubbers in place, like so. That's all finished and designed. All designed by me, of course. And this is the base unit. It's actually my eye on the glove itself. I drew it and took ages to give it my own touch. So this is the way the data glove will look. It will sit on the wrist. Base box and control box, battery box, and box for sensors, the control circuit, and then the rubber will sit in between them, and it'll be beautiful. So now moving on to stripping the microwaves. So we're going to get two microwaves actually, because we want two transformers. So these transformers are used for the magnetron of the transformer. I think they are about the secondary winding has stepped up to, I don't know, maybe 20,000 volts. But I'll be stepping it the other way. I'll be stepping it down the way. Maybe 2 or 3 turns, maybe a wee bit more to reduce the current. So that's it. Moving on now, there's going to be 2 high current cables going to 2 of these on a base unit. Haven't actually got round to thinking what way I'm going to design this yet. Either wood or aluminium, whatever's better. You need a platform to run these through. You need a platform to hold these. Sort of like stealth below the platform. And that's it. So now stripping the microwaves. Enjoy. Okay, so we have the transformer for our cutting machine. So next thing is removing the secondary winding, which is this top one. Just leaving the primary winding in place. So I'm going to do about 3 turns using a high current cable. Okay, so at this stage I thought I would remove the transformer from the other microwave too in a minute, because it's in scrap. Doesn't matter about that, it's only secondary winding. So now we have 2. We might be using the 2 for two different cuts, or I might put the 2 elements in series with the secondary winding for to do 2 different cuts for the actual cutting machine. So there we go. Okay everyone, so I have my 2 transformers. What I need to do now is remove the secondary winding, but basically try not to interfere with the core itself of the transformer. But I'll be cutting down into the secondary winding using the grinder, and I'll be beating it through. It's not the first one I've done, it's probably 10 or 12. I have stripped a lot of them. There's ones over here in the windowsill that are actually rotten by rust, so I decided to just get 2 new ones. Well, not new obviously, but ones that's not covered in rust. The laminates. So okay, going to start cutting this now and taking it apart. The reason I want 2 transformers is because I want 2 separate heating elements on at different times. I don't want to be pushing, turning the primary winding on and having 2 outputs and 2 outputs of 1 transformer, because it means the one will be always lying naked to the hand to get burned, and also it will destroy the little element it being on when it's no need to be on, the little blade. So what I'm going to do is I'm going to have 1 switch for one cutting element, height, and then, or shape, because I can shape this too, remember. And then I'm going to have the other switch for the other cutting element. Okay? So we're going to start this now. Okay, had a mask on there. So here we have the copper windings going through here. What I need to do now is completely remove this without hitting the grinder off these laminates. Don't want to mark them. Importantly, not damaging this primary winding. So what I'm going to do is I'm going to gouge under here with a carbide burr, and try with the grinder too also. Okay, everyone. So I have already I've cut this lump copper off. Obviously loads of pieces of copper wire to wound together in a loop. So basically I've removed the loop out of the loop. What I'm going to do now is I'm going to weaken the actual secondary winding itself, because there's a lot of pressure against the walls inside the core here. So the bigger the hole I bore down the middle without damaging the E and I laminate, the E laminate, the better. Then I will tap the secondary winding out. Usually it doesn't go very easy, but I will do my best to video it here. So enjoy. So I've already started boring the holes here. Down the middle, 8mm hole first, 10mm hole, and that's it. So what do we see here? There we go. Okay everyone, so it's been about a half an hour later. We have the two transformers complete. One for element 1, cutting element 1, and cutting element 2. So you can see here now, when I bring the camera up closer, I'm up close to the camera. The window area, right through where the secondary winding used to be, is completely clean. An insulator is also left, just in place on both of them. One of them is actually harder than the other one to strip for some reason. So just a different manufacturer. So we have this one too, which has a bigger aero window, or window area even. So now moving on to making a platform to sit these on. Don't know what way I'm going to do it yet, but it'll be fun. So clean up this bench first. Okay everyone, back out again. So the platform that I will be using for this system unit will be made out of wood for handiness. The table that the parts will rest on, these rubber mounts will rest on aluminium. I will be able to adjust the table, the guide, or whatever you want to call it, in and out to suit the track and where the track needs to be in the rubbers. So first things first, now I'm going to make up this wee platform for the transformers. So basically one will sit here and the other one will sit here. Okay, so ready to screw this together now. Okay, so the reason I leave where I mount the transformers on outside is because I want as much space in the middle to work with, as there will be rods going up and down. Well, I haven't exactly worked it out yet, but in my head there'll be two rods running up to the heating element to hold it, and these rods will be placed in the timber, as the timber will act as an insulator at both heating elements. Okay, so we're now going to mount the transformers. I'm using these nice stainless screws, good coarse thread on them. So I keep mentioning elements, so let me make that very clear. I'm actually talking about the cutters that will all be heated to approximately 200 degrees. So 2 screws might be enough for this, you know. Okay, now ready for the uprights. So these now will be screwed to here with glue and 50mm screws approximately. and then we will set the top bed or platform on. Okay, so we have that finished now. The next step now is to sort of figure out where the electrodes are going, where I will place these cutters. Obviously they will be running this way, so I'll be cutting the rubbers, sliding them through. This way is no good. This way is better because I'm using there'll be two work positions or work spots. There'll be cutter 1 and cutter 2 coming up through the wood here. And the stroke, so I'll be basically just sliding them, the length of it. I'll be sliding this one, the length of the width, which is about 10mm. I'll be sliding this one, 25mm, to do the 2 cuts, top and bottom, and side. So there we go. Okay everyone, day 2 of this little project. So last night, after I completed this box, probably a couple hours at it, started raining, so I had to go on. So last night I made these wee connectors that holds the cutting tool for the 2 stages that will be on the top of this, the platform. So we have 2 cutters. We have a connector block, or a connector, that holds the cutting tool to a 4.5mm, 5mm rod. This rod will be fixed to the timber with this little sliding connector. So basically what I've done here is I have, let me see if I can get this in the camera here. I have tapped a 5mm hole in one of the holes, existing holes, that used to be some rare size, like, I don't know, it's a wee bit bigger than M4. So this thread is now 5mm, as is this one, and basically in the end up I'll be able to adjust the cutting tool. Let me see if I get it the right way up. I'll be able to adjust the cutting tool height using this. So at the back, these connector blocks need to be isolated from each other, so it isn't short circuited here at this point. So basically you want the current to go through here, not here at the brackets. So this will be isolated by attached to the wood at 2 points using 2 separate brackets. So these brackets will be mounted to these 5mm holes that I have tapped on this connector. So I'm just going to give it a wee close up here. So we have these wee brackets that I have made here with the screw and all cut. So small, so these screw onto here. See if I can get it on here now. I'll get the Allen key here in a few seconds. So let me see. I have a sore finger here. You can see the tape on my finger, so bear with me. Okay, so we have this bracket on now. So basically, this bracket screws to the timber. So this 5mm dome stainless screw doesn't interfere with the bar, the electrode, or whatever you want to call it, in behind or on through it. And that will be the same at this side. So when let me see if I can get in the camera here. When I have this placed against the timber, these uprights, this upright will be screwed onto here, and basically we will have this sliding up and down of the timber into the platform that I will put on it. Okay, so I'm going to give another wee just a wee demonstration here of something, a wee problem. So this plate that I have made will screw to the timber, okay, like so, in 2 places. There'll be 2 of them, and they will go on like that. So I now have to alter this bracket, so I have to put a wee fold in this bracket and TIG weld it to this lower one. So basically I want this nice, strong, I want the cutting element sturdy so it doesn't move when I'm leaving the nice fine track in the rubber. So what I'm going to do now is I'm going to go and fold, got a wee fold in 4 of these brackets. I'm going to put a fold in each one of these wee brackets that I have made here. What do you see? In the background, or on the face there, you can see a wee black mark. That's where I want to fold. So basically I'll be folding it at the start of that hole, and I'll then will be trimming it. I will trim it to max, file it or grind it until that connector block or that plate is sitting parallel to the timber. Okay. So I want the connector block sitting tight when I screw it to the timber for extra support. So it's more sturdy than just hanging there with one screw on the connector block. Do you understand? So that's it. We're going to move on now to folding them, then we will TIG weld the brackets together. We will screw 2 of these to the platform. Bring the camera up close here now. So here is the platform, or the wee base unit that I have made. So what I'm going to do is I'm going to screw this to one side, probably about 200mm apart, another one. Obviously the stroke that I will be sliding these is only the width of the rubber, so basically 30mm. So I'll keep them a little bit apart. So we have transformer 1, transformer 2. I will wind these in after I finish off the flat platform and the cutting tools. Finish off that end of it first. When these top uprights is on, they're going to need 2 supports, 2 triangle supports. So I'm going to demonstrate doing this all now in a wee minute after fold these and weld these first. There will also be another support on this one at this side, and then we will have the bed. So the bed will be the bit the rubber slide on, and there'll be a switch beside the first cutting tool and a switch beside the second cutting tool. And what else do I need to explain here before going further? I think I've covered everything. Okay, so there'll be a guide at the back to determine where the groove will be placed from this face. So I want it the same as my wee glove parts, but they're not there today. So yeah, I'm going to move on now to folding these and welding them, and that's it. Enjoy. Okay everyone, so we have these wee brackets here sitting here ready. They are 3mm thick. Not necessarily required, the thickness, but that's all I had. Still, so I'm going to start folding these now, and hopefully it works out okay because they're quite small. Maybe should have folded them first, but I was in a rush. There's no problem folding these. Okay, so we have these 4 brackets. Just assembling them now, so it's 2 pieces to each bracket. I'm not going to lift this one because it's obviously hot. So basically, well, if you want to see more detailed pictures and building these brackets, see the images at the end of this video. So so what do you see now? So this stainless steel is sort of mimicking the way the flat surface, right? Off the timber, of course, when it's on the project. So here we have the wee brackets. That's actually this side, so right hand side. So this bracket holds that connector block to the timber tight. See the way the brass block's tight there now? There's very tolerance is small between it, so there's no gaps between it. From this height, it's 6mm from the face, top face to the bottom face. And when I put a screw in this now and a screw into here into the timber, this end will be isolated from this end. So I'm going to tack up the rest of these brackets here now. As I've mentioned, if you want to see the folding or the cutting of these pieces, please see the images at the end. So 2 rights, 2 lefts. They're a wee bit tricky to get together here, so bear with me. So very tricky to get together here, it's so small. But that's that one tack now too. That's 2 done at the back anyway. So that is a left, and this is a right. Like so. Three done. Whoop. Well, I'm going to weld the back side of them too with a wee bit of rod, a bit of filler rod. So footery. 4th one tacked. 4th one done. Woo. So basically, in behind here, I'm going to weld the front face of them here now. I'm just going to weld here and here now. Hot, really hot there, my finger on it. So quite neat, these brackets. So these will always be isolated from each other because of the insulator wood between them. And so the heat under the wood, there won't be that much heat. The heat will go to the cutter for all the length of the time the cutter will be on. And so I'm going to finish off welding these now. I'll take pictures right through the stages. Please see them at the end. That's it. Okay, that's it, I'm finished. We will finish off the timber now, and then we will the timber frame, and then we will assemble the whole thing and wind the transformers and install circuits for the input for the transformer and see how it goes then. Well, also we have to do the tray or the table for the top. Okay everyone, so the wee connectors, the wee brackets are all finished, and they are, you can see them here, sliding up and down. This, I think it's close to 5mm bar, 4mm, 4.5. Okay, so if I want to lock this up, all I need to do is tighten the screw at the bottom here. Then the heating element, or the heating cutter, is fixed in a position. So there'll be 2 workstations, right? So there'll be one for cutting a different groove and one for cutting this groove in the rubber. This rubber. Okay, so I have actually 16 data gloves, so you can see why I'm making this. I've made 16 data gloves, smart gloves. So I need 16 connectors, and they need to be perfect for my head. So it's starting to rain now. So what I want here, right, is I want this connector just tapping the top of this platform. It will be mounted onto the transformers. The sort of wood fixture frame that I already have made here. So there will be 2 holes bored here, or 1 hole for the 2 cables, both sides, because there will be cables coming up from both secondary windings of both transformers. So what I'm going to do now is I'm going to make another one of these, and then we're going to make a nice angle support. Then we will start attaching these few things that I have made up, and hopefully it all works out. Then we will start winding we're setting the windings in the transformer, secondary winding, using this 10mm square cable. So I should point out, these connector blocks are rated for, I think it's 15 amps. Well, it's 15 amps AC. So I'm putting current back through them. It's much greater than that, but I will only be applying that current for a second or 2, or if not less. I don't know the way it's going to work out yet. So we'll see how it goes. So we're going to try and cut these with supports first, 45-degree angle. Oh, aye, making a video. You want to star in it?
No.
Huh?
No,
for Facebook, or not Facebook, my YouTube, making a wee thing for my smart glove. One done, another now. So we'll give these a wee sanding up now, and then we will cut the last one of these for the other cutters, supports, for the mount that we'll place here. Okay, so that's all the wood work finished, just a wee sanding now. So give these a wee sand. Okay, so screw this together now. I'm going to bring the camera up close. So I'm going to sit down here. So this is what the bottom looks like, below the platform. So basically now I'll have the two cutters going up the side, one going up the side. They've been mounted with bolts. The reason I'm using bolts is because I don't want the screws to slacken. Because these heating, what do you call them, the connector blocks will most likely burn the wood a wee bit with the current. So they might sink in a wee bit. So what I'm going to do is just put ordinary stainless bolts to hold the brackets that I have made previously. So screw this together now and glue it together, and then we'll attach the cutters, the cables, and then we'll think about making the bed, the platform that I will slide the cutters on for this task, and then this one. So basically I will probably do the deep cuts first and the shallow cuts second, and that's it. So enjoy. So before I go any further about screwing these all together, I'm going to bore the two holes on each of the frames or wooden supports or uprights, whatever you want to call them. So keeping in mind, we want this cutter to be just touching the top when the brackets are at its highest point, if that makes sense. So what I'm saying here is I want the brackets to be as high as possible to avoid any sway. This way when I'm pushing the rubber into the cutting tool. So the higher the brackets are, the better. With the cutting tool down below the bed. That's what I'm trying to say. So they have to be also as tight as possible, because the groove that I will be cutting will be very, I think is about 2 mm wide. It's very small. So once I put heat into this cutting tool, it'll hopefully take its shape. I don't want to put too much pressure on it at the minute. I don't want it to break. So bore these holes now just. Okay, so we have two marks on this, center mark and the mark for the height. It's approximately about 45 mm down from the face, the top face. So we want these as close as possible without them touching. So I'm going to put my first hole here. Okay, so we can screw this together now. Okay, so let's set up marked where I'm going to bore pilot holes. So we'll have two screws coming up from the bottom from this upright. We will also have two coming up from the bottom from this side, and then we will have two screws basically just to hold this and make it more sturdy. So bore these pilot holes now. See the mark here I have laid out. Okay, so I started mounting these wee brackets for the first workplace. So I'm going to mount second ones here now, just on camera. So 3 bolts, all cut specifically to size, so they're not too long. So that's it. 2 work points. Well, all I need now is a cutting. So I should point out here, I didn't go into detail on these. So these wee cutting tools are for tires, as I've mentioned at the start of this video. So this is a type. They're 3 to 5 mil wide. I'm hoping to get them down a lot narrower when I apply heat through them. I need this radius, maybe at about a 1.5 mil radius. At the minute it's much bigger than that. I'd say it's about 3. So next thing now is to bore the holes, start winding the transformers, and think about some sort of a nice base, or sorry, what do you call it, top layer here, bed that I can slide these on through the cutting tools and a guide. So we're getting there slowly. Okay, so next step is boring the holes for the high current cables, and the cable I'm running through here is 10 mil squared, so a hole within region of 10 or 12 mil, enough player in it. Then we'll move on to winding the transformers themselves. So here we go. Not the neatest holes, but do the job. Okay, hopefully you can see me there. So I have removed the transformers from the structure that I've made. So we have 2 cables now, 1.5 meters long, 10 mil squared, tri-rated, electrical cable, bought it at my local electrical store. So what I'm going to do here now is I'm going to wind the 2 transformers, secondary winding. So if I need to increase the current in the future, I just remove 1 loop. Okay, so what I'm going to do in the meantime is I'm going to maybe 3 loops, 4 loops. So here we go. 4 turns, and we'll do the same with this one now. And if I need to decrease it, if the current's not great enough, big enough, I will adjust it. I'll just be removing 1 of the loops when it's in the structure. Okay, so we want the second one now. Tails coming out opposite end from the primary connections, just to suit the structure that I built here. So again, same length approximately, 4 turns. What I like to do is keep them a wee bit slack to start, so I get the 4th turn on. There we go, so we can tighten the cables up now with our hands, just by pulling them gently, working them into position. Okay, that's it. Ready to mount back in to the unit itself. Okay, so just before we do that, going to make up the wiring for the primary windings, and just so it's removes any awkwardness when I go to try and place these wires on the transformers in the unit. Okay, so that's them ready to place back into the unit. Put the high current cables up through the holes. Okay, so as you can see, I went ahead and more or less finished this project. I've took many of photos. So here's the 2 transformers, wired and all. Secondary output, 2 10 mil squared cables. 2 the elements, or the cutting tools, on each side here. So this switch operates, it's off at the minute. Might put it on just 2 seconds. So I'm about to cut this sheet for the platform. So basically the lines is fine there, it's just a pencil. So I have, a sheet, 250mm with 2 folds in it. So basically I'll have a nice wee table here on top of this with 2 very small holes with these cutting, these pieces of cutting elements will come up through, cutting tools. So at the minute they're slack. So it's important here that I don't put too much heat into these because you can distort them. And basically just touching the switch that gets enough to cut the rubber. I could demonstrate that, but the problem is with the camera in the hand, so I've already tried it, but I'll do it in a minute. Okay, so round to the back here. So we have the income supply, 13 amp supply. Only one side will ever be used at once. I don't know what current it's pulling in the input, but I'm sure it's not that big. And okay, so we have the live neutrals to each side. We have both transformers earthed to prevent any electric shocks. So basically, just say that one of the windings came live to the body. I don't want to get shocked, so they're both grounded. And what else? I'll put her over on her side maybe. All the pictures at the end will shows the wiring of this. Very simple, but it's nice. It works well. So what I'm going to do now, right, is I'm going to do one wee demonstration, just cutting the rubber for the first time, and then I will make the platform, put the platform on, make the guide at the back, 2 guides actually. No, well, yeah, I can make 2 guides, different heights, yeah, or just a clamping device or something simple, nothing overly complicated. So I'm going to put the camera on here, like, we'll take a chunk out of this rubber to show how well it works. So as you can see here too, I've also slanted this. This is to keep the heat away from the wood. I don't think it's going to get that warm anyway, because basically I'm only hitting the switch for a matter of milliseconds. So what do we see? The current's very, very large from the transformers. So I'll try and get a wee close up here. I'll use this workstation on the right first. So at the minute I have the cutting tools sitting there. Right, okay, so we have 1 rubber for the glove. See if I can see what I'm doing here. So we have 1 rubber with no groove in it. No groove here, okay? So what I'll do now is I'll just nudge the switch and cut straight through it with no guide. Obviously, because there's no platform on it. Okay, so here we go. Look at that, beautiful. So see the nice wee, obviously I pulled it up a little bit, but hopefully you can see it there in the camera, the nice wee clean cut. Works really well, so it does. Just need a guide now and a table, a platform. Okay, so in the garage here. So I just cut this wee bed, right? So I'm now ready to give it 2 folds just to strengthen it. So this is basically the platform that I will be running the rubbers against. The 2 cutting tools will come up through 2 wee small holes, 200mm apart. So here we go. So here we go. Bed done. Okay everyone, so that is the top plate bed finished. So basically that just screws on to, let me see. So that screws on now to the top timber pieces here where I've bored the pilot holes. Drilled the wee small pilot holes here. So this bed is held on with these long thin screws, 3mm screws. So next step now is making the guide for this. So I've marked here and all already. So basically I will be using this aluminium 20mm box that will slide back and forward just over 10mm 10mm adjustment on it, because the rubber itself is, well, depth of the cut's not that much. So if you can imagine it sitting here with the cutter here, this box iron will be sitting pretty close to the wee cutter for the heating element, heating cutter. So what I need to do now is cut this box iron, work out a way I'm going to adjust this, either using wing nuts. Might be a wee bit impossible to get the wing nuts in here now because the base is short. It's close to the support, it's wooden support, but we will start cutting it here now and we'll see how it goes. One guide. Okay, so I have cut a notch out of this here. So this is basically to allow well, access to slackening the nut or bolt, whatever's going to go down through it. I haven't made my mind up yet, but I have to cut this side now, so. Okay, so give us a wee filing now and give a wee clean up. Okay, so that's the guide finished. Now ready to, well, I have to bore the holes in the platform or the slot to allow this guide to slide, approximately 10mm. Okay, so boring holes or slots, boring holes first on this plate, and then we will shape them out to nice slots that will allow me to adjust the guide over 10mm approximately. Okay, so what I need to do here now is cut the rest, link these holes together using the Dremel. Okay, so not far away at that. Finished. Remove the burr now and that's it, done. Great job. Hopefully you can see me there. Okay, so to finish off this wee project, I came up with something last night. So I had issues with on the first initial test. So I had issues with cutting the rubber and the rubber going on fire. Too much heat, so too much current. So what I have done now is, well, I haven't done it yet. So rather than using two transformers, two different tasks, two different cuts, what I'm doing now is I'm putting the two transformers in series. Doing this reduces the voltage on the primary winding, well, between the first transformer, the 120 volts, and then the second one, the 120 volts. This also reduces the current, so basically half the current means half the current in the primary winding means half the current on the secondary winding, so that's what I need. So I'm going to bring the video up here now and do a wee walk around on the wee trial test that I'm going to be doing here. So I have a clamp meter sitting here ready, and the clamp meter is set to 0. So before I had the two transformers in parallel, I previously disconnected that just to sample them in series, and then I have now put one of them back into, well, just 230 volts across it, and don't pay no heed to the colours of the wires. There's a live and a neutral running in here, just one switch now, so we aren't using two switches no more, we're just using one. We have 6mm cable across the connector where the cutting element will be, cutting tool or cutting knife. This is just so I don't burn out my cutting blades themselves. So I'm ready to rock here now to sample this. So I'll set this meter to 0. Yeah, here. Okay, so I'm set now, ready to rock. So here we go. Maximum current be 230 volts. 4 turns of the winding. Okay, so that didn't work. Holds on, sorry. Okay. Set this to 0 again. Okay, near enough. So, there, 500. Oh, hello again. So the hotter the wires get, the current's not going to be as great. The resistance changes. So, it shows you here that it peaked at 500 amps. So what I am expecting now when I put the two transformers and the series and the one big loop will be half that. Will be approximately 250 amps. So this will save my cutting knives tool. So what do I just go again one more time? Okay, so 400. The wires are quite hot now. So remember, that's 4 turns of the winding. I can't reduce the current anymore because the window area of the winding is full with 10mm squared cable. So now I'm going to set this up in series very quickly. Won't take long. Might just keep the camera running here. Okay, that's it. So now we have the second transformer. This side is now on the circuit. So now the meter is set at 0. I'll put the plug in here just. Okay, so she's powered up again now. So when I hit the switch, you should see half the current now and also half the voltage across here if I put a multimeter on it. If I remove the link. But I'm interested in the current here, so hopefully this is half now. Hopefully 200 but 250. Oh, that beautiful now. Half the current. Very smart. Okay, so the last thing now is obviously removing these pieces of wire again. So as I've mentioned here, I've just put these in here to complete the circuit for the meter. So I'll just take the 2 of these off again and put the cutting tools on and put on my bed and the nice guide that I have made. So you can see the slots here now. They finish it. Okay, so to finish this off now, I can remove this switch, not need it no more. Don't need them connections. We can attach the bed. Looks good. So we have screws here, they're quite long. Okay, now the guide. Backstop. So this can be adjusted to suit the cut depth on the rubber. So this can be adjusted now, back and forward, like so, to the cutting tools, or the cutting knives, sorry. Keep saying tools, right, okay, so tighten this up and do test. Okay everyone, beautiful day again. So hopefully some of you has watched the whole video rather than just skipping to the actual final piece, but if you have skipped to this, this is the interesting part. So does it work? It works very well. So my little system that I have built to cut tracks in rubber, resin material. So again, to point out, the reason I have actually not printed the grooves in this is because it's very difficult because of how flexible the rubber is itself. So what I'm going to do now, right, I'm going to do a demonstration of cutting the 4 sides, 2 deep sides, 2 shallow sides. So this is a shallow side cutter, and this is the higher side, the side for the deeper grooves. So basically for the rubber sitting this way, and then the rubber sitting flat. So on the end up, this rubber should slide in to the actual glove control box, as I've discussed at the start of this video. So what I'm going to do now, right, is give a wee quick demonstration of why I built this, so, or what wee discussion even, sorry. So this one is cut with a Stanley knife, and as you can see, it's very rough. It's very hard to do because the rubber's so soft, and if a knife slips the slightest wee bit or goes on too far, it makes the rubber weak. So these knife aids create a nice radius curve. No sharp edges is going down the way. It's a nice continuous curve of height. So the rubber is still strong and they end up and it's not likely to break, if that makes sense. So the guide is ready, ready to rock at the back. It's not set up perfect at the minute, but it's near enough. So what I'm going to do here now is put a bit of cream on this bar. So I discussed this wee bar to start about making a wee support. So this support is basically just to see the way this rubber is really flexible. It's to take out that flexibility to strengthen it. So we can't bend it now, and it's much more sturdy for me to cut the grooves. So it's really good. So what I'm going to do now is cut the deep curve, or the deep grooves first. Then we will do the shallow grooves at the bottom and the top second. Again, this wee project was handmade, just designed by me out of 2 microwave transformers, 2 cutters out of for tire machine for cutting treads and tires. I don't know, motorbike tires or something. They're only 3mm wide. I have squeezed them a wee bit more to get down to 2mm, but I'm going to demonstrate this working now, and I hope you enjoy it. So what we'll do here is keep the camera rolling. I'll bring the camera right up close and bring it round to the cutting tool end, and hopefully you can see it working to its best capability. So let me see if I move this chair. Okay, so might zoom in, you know, too. Okay, that's a good angle there, I think. So we'll zoom into the cutting tool and the guide. So it's set now near enough. Actually, I'll zoom out so you can see me using the switch and stuff. Okay, so the piece of the reinforced bar, reinforcements, and then inside you can see it there through the translucent material. So the Jenga block, or sorry, a piece of wood or a Jenga block is used as a guide, sort of like to push the piece of rubber into the element, the cutter. As it's going to be hot, it's going to be 200 degrees, 250 degrees. As demonstrated earlier, the current is quite high. So because the 2 transformers are in series, I have half the current on the output of the transformer, so that's actually quite good. So the rubber doesn't go on fire, or also it doesn't tarnish the rubber. So without going on too much here now, I'm going to just cut this straight away. So set the piece of rubber up against the cutting tool on its edge, pushing the Jenga block and not the rubber, but just making sure that the rubber is sitting nice and neat to the guide also. So away we go now, pushing the switch and pushing the Jenga block. Look at that, isn't she beautiful? So you can see here the cut is left is immaculate compared to the likes of this one. As you can see, I cut it with a knife. I'll take pictures of these too and add them in the end just to show the difference. So what I'm going to do now is I'm going to remove the piece of rubber out of the cutting tool here, the cutting element. So there it is, really neat cut. So I have 16 of these to do because I bought 16 smart gloves, believe it or not. So what I'm going to do now is going to finish off doing the cuts in this one, and then we'll finish up this video, and there we go. That's as easy as that. Works so well. And next thing I'll do now is move on to this side, so I'll bring the camera over to this one. Get a better angle just. Let me see if I can zoom in maybe, or put everything right over. I think it'll be a better idea. So again, you can see the marks been left in the Jenga block. So that's just showing you that I'm cutting straight through the rubber. So the reason I'm using the Jenga block is because it keeps the rubber nice and nice shape. It keeps its shape right through the process, the cutting process. If I was to try and slide this through the cutting tools, I guess the rubber would move because it's that soft. And you know, it's really soft. So now we're going to demonstrate cutting the shallow side. Same process again, sliding it through. Only this time I have to use my knee in the switch because my hands is over here. Quite tricky, but okay, so it's quite tricky with the switching mechanism, but you can see there a wee groove up the side too. So I forgot to remove the piece of rubber out of this side, so that's why you've seen the smoke. It's out there now, so you should always remember to remove the rubber before you start cutting out of the other work table. Okay, so that's the one wall going there, you can hear it. So Again, cutting this lower groove. So there we have it. One complete rubber. Okay everyone, just to finish up this little video here, so we have two pieces, the component that I cut there now, the rubber, piece of resin. So here we have the little rubber here now, so the slot's cut, sliding into the control box that sits on the hand. I forgot to do one thing here, stick a bit of metal out on the side of it. Hold on. That's why it's a wee bit tight. So there we go, out. Sorry, just to show that the bit of metal was still on it there. So here we have the piece of rubber. There we go. So the jointer is now connected to the control box. This can be placed in using a bit of iodide glue. It fits like a glove. Get it? Okay, so this basically sits on the hand here, and then we have the wrist box slides into another groove. This is not cut yet, obviously. Then we have a bit of iodide on it to keep anybody from pulling it out. We're bringing it up to close, so you can see it's quite firm anyway and quite snug on the control box. So the lid then is placed over the top of it. It clips it in and holds it in position so it can't come out. So you're probably thinking why I've made this machine for that. Well, I've bought 16 smart gloves, so the 16 smart gloves need rubbers, 16 rubbers, and these need 2 rubbers or 2 cuts, 2 grooves on each rubber. That's why I've bought this unit. So that is part of the smart glove. I'll take this off just to show you again. So that's the clip, and this piece of rubber just slides out. You can see the nice grooves on it, so it's really good. Okay, so to wrap this video up, this little piece, there was a lot of work on it, from these transformers, removing the old secondary windings to replacing them with my new secondary winding. I think it's 4 turns, 1, 2, 3, 4 turns. These little connections at the 2 workstations here, 2 work points, and here was the most footeriest part of it. The platform and the guide was much simpler, and that's it. I hope you enjoyed the little workpiece. If you want to see more interesting projects coming in the future, subscribe and like. There will be a unique piece coming in 1 month's time, and it is a world-class project. It took multiple attempts to get it to work, and it's quite the workpiece. So thank you for watching everyone, and bye bye. Okay, so I forgot to mention there the additional manufacturing photos was going to follow. So just a few images here of the transformer being stripped. So secondary winding being removed completely without damaging the core or the primary winding itself. So special attention was given when I was boring down the center of the copper window area, or the winding window area of the transformer. So this is the little brackets being finished up. There's 8 pieces all together to make the 4 brackets. This is the little connector block, rated at 15 amp, being tapped out to M5 with an M5 tap. So this is the little brackets all nearly assembled, and using the little bars that I have bent there and a wee angle for the cables, with the connector blocks all attached. At this stage, these wee brackets are ready to be welded. Probably the most time-consuming job throughout this whole project. Well, apart from the transformers. So there's 4 of these. This is them finally welded. So welded back and the front. The then were attached to the timber, the bollards or the uprights or whatever you want to call them. So this is them mounted using M5 bolts again. Cap bolts this time. So the transformers at this stage were also wound using the 10mm squared cables. So the cables in total length were 1.5 meters each, 3 meters in total that I purchased, and these were attached directly into the connector block, into the bottom of the wee angled parts there. You can see that I have angled out away from the timber. So this is just a demo or wee illustration of me finishing wiring it all up. And so at the start these were wired in parallel, and then to half the voltage on the current on the secondary winding, I split the voltage on the input of the transformer. So this came in later stages. You probably see me using 2 switches at this stage. However, this was completely changed to 1 switch to control the whole unit. This is the stainless steel sheet that was used for the top platform, and I demoed in the video there and the folding of it, the 2 edges, and why them edges were there. So basically just to strengthen the top work platform, and that's really it. So the guide here, just a piece of aluminium, 20mm box. This notch was cut out to allow the wing nut room to turn. There was also a spacer used here, as you probably would have seen in the video clips, to keep the wing nuts from hitting the edges there. So this is the platform, drilled, ready to be grooved at this stage, and obviously you have also seen this in the video of me using the clamp meter to monitor the current on the secondary windings. So that's it, everybody. Thank you for watching, everybody, and please come again for more interesting projects. Don't forget to subscribe and like. Thank you, bye bye.